Hello all, this is Priyadharshini from third year BTech IT, and this is the video submission for the RECode challenge. In this video, we are going to solve a problem given in the PAT portal. First, let us understand the problem statement. Given an integer n, and we have to create the array of size 2n and return the array filled with two instances of each number from 1 to n. And the condition given here is for each number x, the two occurrences of x should be separated by x other elements. That is, they should be placed at x plus 1 position apart in the array. For a better understanding, let's see some examples. For the input n equal to 3, the output array should be in the size of 6, that is 2n. The first element 3 is placed after 3 positions, and the second element 1 is placed after 1 position, and the third element 2 is placed after 2 position. Likewise, all the numbers should be placed from 1 to n. If such an array is not possible to create, the output should be printed as not possible. Here is the algorithm using backtracking approach. Why backtracking is this problem has more than one solution, so we are solving this problem using backtracking approach. First, we are creating an array of size 2n and initialize it with minus 1. Then start with the largest number n and try to place the two occurrences of the number x in the array such that the two occurrences are in x plus 1 positions apart. For each number x, try to place at index I and I plus x plus 1. Also ensure the both positions are empty, that is filled with minus 1. If placing a number leads to an invalid configuration where the next number cannot be placed, here comes the backtracking. Undo the last placement and try a different place for the current number and give a base condition. When all numbers from n to 1 are successfully placed, return the filled array. If it is not possible to place a number, return the output as not possible. Let's see the code and how it works. In the main function, we are calling the fill with one method by passing the value n. In this function, we are creating an array of size 2n and initially we are filling it with minus 1. Here we are calling the fill array function by passing the array and the n value. This goes here. Here the current value is equal to the n value. First it checks for the base condition that whether the current value is 0 or not. It's not satisfied, so it goes into the loop. For the current number 3, it checks for the 0th and the 4th position. The both positions are filled with minus 1, so the 3 is placed in the 0th and 4th position. After placing the 3, the current value is decremented by 1 and now the current value is equal to 2. It again checks for the base condition. It's not satisfied, so it goes into the loop. First it checks for the 0th and the third position. The 0th position is already filled with 3. So the I value is incremented by 1. Now it checks for the first and the fourth position. The fourth position is already filled with 3. So the I value is incremented by 1. Now it checks for the second and fifth position. Both positions are filled with minus 1. So the current value 2 is placed in the second and fifth position. After placing the second element, the current value is decremented by 1. Now the current value is equal to 1. It again checks for the base condition. It's not satisfied, so it goes into the loop. It first checks for the 0th and the second position. Both positions are already filled. Then the I value is incremented by 1. Now it checks for the first and the third position. Both positions are filled with minus 1 only. So the current value 1 is placed at first and the third position. After placing the 1, the current value is again decremented by 1. Now the current value is equal to 0. It satisfies the base condition, so it goes here and returns the filled array. For the input 2, it checks for the 0th and third position. Both are filled with minus 1 only, so the 2 is placed in the 0th and third position. After placing the 2, the current value is decremented by 1 and now the current value is equal to 1. First it checks for the 0th and second position. The 0th position is already filled and then it checks for the first and third position. The third position is already filled and then it checks for the second and fourth position. It goes out of the array, so it returns false and it is printed as not possible. The time complexity of this problem would be the O of n square. While executing the code, all test cases are passing. Now let's check for the test custom input. For the input 4, it returns the array, and for the input 2, it returns not possible. Here's the two real-time application of this problem. One is memory allocation in operating system like task scheduling, and another one is data replication. If we need to replicate data blocks and store them in separate memory locations to avoid access conflicts, we might require the blocks to be placed with specific gaps between them, like this array construction problem. By this, I am concluding the presentation. Thank you.